So for this set of notes, we're going to talk about geometric angle pairs and their equation significance, but first the angle pairs. So you'll see the first pair is vertical angles, and those are two angles formed by intersecting lines that share a vertex and are opposite from each other. Vertical angles are congruent. Having them be congruent is the significance here. So we're kind of looking at them being important because they're congruent. So they're formed when two lines intersect. So I need to draw two intersecting lines, and they share a vertex. So that's that meeting point at the corner of the angle. And they are congruent to each other. So I'm going to show a little hash mark. That hash mark in geometry means that those angles are congruent. And of course they would be congruent in the other direction as well. So two pairs of vertical angles created with each two intersecting lines. And then we have over by the vocabulary word, I'm just going to draw a little kind of memory device for vertical angles where you can write the word vertical angles just to kind of remember how they're formed. The next significant angle pairs are complementary angles, and those are two angles that whose sum is 90 degrees. And there's two ways that that can occur. You can either just have two angles that are kind of separate from each other, but if you would add them up, they would equal 90 degrees. So let's say this one would be 40 degrees and this would be 50 degrees, just approximating there. If they would add up those two to 90, those two angles would be complementary. You can also have complementary angles that create a right angle. That would be if they are. So our next set of angle pairs is complementary angles, and those are two angles that will add up to 90 degrees. So maybe you have two angles that are, when you add and measure and add them, like let's just keeping it simple. If this were 40 degrees and this angle were 50 degrees, they would be complementary because they add up to 90. Now that pair is not next to each other, they're not adjacent, but they could be adjacent. So you could have a complementary pair of angles that are formed kind of inside a right angle pair. So I have a right angle. I know it's a right angle because of the little box, but it's really made up of two angles. Again, I'll just kind of estimate 40 and 50 degrees, and we know they're complementary because they make a right angle, so that's another way to have a complementary pair. Two angles are supplementary if the sum of their measures is 180. So each angle is the supplement of the other. So again, we can have supplementary angles just like the complementary ones that are adjacent. So if I have a straight angle, then I know that the two angles that make it, like if I have a straight angle, that's 180 degrees. So the two angles that make up that linear pair or supplementary angles would add up to 180. So let's just say this is 120 degrees and this is 60 degrees, then those are supplementary. Now I can have the same kind of thing even if they are two separate angles. If they are not attached, that's okay. They just have to add up to 180 degrees. So another important vocabulary word is an angle bisector. And bisecting just means you're cutting it into half. So if we have an angle and then we have an angle bisector, that angle bisector cuts that angle perfectly in half. Now what's important about that is if you have an angle bisector, then it creates congruent angles. And we're always concerned about the measurements, so you know that those two angles would be congruent, would be mathematically significant. And that, you know, that can be for any size angle. You know, I could have an obtuse angle here, and if I have an angle bisector, it's cutting that angle into half. So cutting creating two congruent angles. So again, those two halves would be the same. So the next part has to do with the transversal, and that's a line that intersects two parallel lines. I'm going to zoom in on this picture because we're going to look at several different pairs with that transversal. So let me just we've got transversal occurs when we have parallel lines, so I'm going to draw my parallel lines here in green. And then the transversal is the purple line. That's going to be a line that intersects those two parallel lines. So let's take a look at that and just make sure we're clarifying that this is the transversal. And that is true if the two lines are parallel to each other. That's the symbol there for parallels, two little parallel lines. Okay, for the next angle pair we have corresponding angles, and these angles are in the same relative position along the transversal. So you only have this kind of angle pair when you have a transversal already. So you can see I've just kind of taken my screenshot of my transversal there, and you're going to draw the transversal, two parallel lines and a transversal in that spot, and then we'll redo that. So you're going to see me take that transversal picture with corresponding angles, and I'm going to zoom in on that so that we can take a closer look at corresponding angles and the other pairs as well. Now, corresponding angles, so that's the pair we're looking at right now. And I'm going to color code those. They are in the same relative place along the transversal. So what happens when this transversal cuts through the two parallel lines is it creates two spots of angles, two kind of intersections of angles. And corresponding angles are in the same relative place along there. So we have corresponding angles like this angle is corresponding to this angle. In their crossings with the transversal, they are both in the upper right portion. And so those are congruent. That's the important part about corresponding angles. When you spot them, you know they're congruent or they have the same measure. This angle in the upper left of its group will correspond to this angle in the upper left of its group, and they will be congruent. Again, it's the fact that the measurements are the same that's important. This angle on the lower left would be congruent here to the angle here in the lower left. I'm going to change that orange one to have two hash marks there to match. And then on the bottom right, we have corresponding angles with the bottom right. And the key would be those corresponding angles are congruent. If you can spot that they're in the same place along a transversal and parallel line, you know they have the same measure, and that's why they're important. All right, so the next pair, alternate exterior angles, these are also along the transversal, and this time they are on opposite sides of the transversal and outside the lines. And again, the importance is that they're congruent. The idea is if we can find congruent pairs, then we know that their measures match. Now, because these are still formed when the transversal crosses parallel lines, I'm going to get that parallel line transversal drawing. So again, we want to take that parallel line transversal drawing, and I'm going to zoom in on that, and let's take a closer look at that. So this time we're looking at alternate exterior angles. Again, the focus is on the fact that in the transversal, when that transversal crosses the parallel lines, it creates two sets of angles. Alternate exterior angles will be on opposite sides of the transversal, and outside exterior to the parallel lines, and they will be congruent. So those two angles will be congruent. Alternate exterior, this angle is alternate exterior to this angle, and so those two angles are congruent. Again, notice alternate, that's opposite sides of the transversal, so opposite sides of the purple line there, and outside the parallel lines, that's the exterior part. The next congruent angle pair are alternate interior angles. Again, these are on opposite sides of the transversal. They have to do with the transversal. They're going to be inside the parallel lines that they intersect, and again, they are congruent. So we're looking for congruent angle pairs so that our measures match, and we have information about the measures. Again, because this happens on the transversal, I'm going to pull up that transversal drawing. So we have two parallel lines in a transversal, and I'm going to zoom in on that, and we're going to talk about that with alternate interior angles as well. All right, so alternate interior angles, again, we're looking at those sets of angles that a transversal intersecting with parallel lines creates, and these are going to be on opposite sides of the transversal, but interior, inside the parallel lines. So those two angles are congruent. Those are alternate interior angles. And also alternate interior are these two angles. So now you have a whole list of congruent angles to check on measures. You have complementary, supplementary, and angle bisectors. So we'll be looking more at those measurements in a little bit. So continuing our angle relationships, you want your notes template for angle equation relationships, and there's a warm-up there. We want 3 types of angles. Draw each and write your own definition. I'd like you to pause the video and then check your work. Alright, so hopefully you had 3 angle types written down. I had acute, obtuse, straight. You could have also had right as an alternative. So hopefully kind of recalling those angle types. Now we're going to look more at angle relationships. So the first angle relationship that we're going to talk about are complementary angles, and we looked at these in the notes earlier. You could have those notes out with you, and we need to think about that definition. So complementary angles are 2 or more angles that add up to 90 degrees. So we could say that the measure of angle 1 plus the measure of angle 2, please note the geometric kind of measure notation there, is equal to 90 degrees if they are complementary. Now we can do a picture for that, and you had the picture in the previous notes, but one of the easiest ways to spot complementary angles are the pair of angles that occur inside a right angle. So we'll just call this angle 1 and this angle 2, and then that kind of refers to that statement up there. The next angle relationship we need to focus on is supplementary angles. Again, that was in the previous notes, so you could have those out. Think about that definition. So supplementary angles are 2 or more angles that whose measures will add up to 180 degrees. And we can draw a picture of that. If we have a straight angle and we have 2 angles that create that, that's called a linear pair. But those angles would add up to 180 degrees there. And so we'll just call this angle 3 here, and this will be angle number 4. And so looking at that picture, we can say the measure of angle 3 plus the measure of angle 4 would equal 180 degrees. So angle 3 and angle 4 would be a supplementary pair. Another angle relationship that we'll focus on is vertical angles. Again, those were in the previous notes. Vertical angles are formed when 2 lines intersect, and what's important about them is that they are congruent. So vertical angles are angles opposite each other when 2 lines intersect. What's important about them is that they are congruent. And then I have that symbol there. That is a symbol you want to get familiar with. That is a symbol for congruent. It looks like a equal sign with a little squiggly on top of it. And again, this is that vertical angles oops, angles, there we go. So vertical angles are formed across from each other. They are congruent. So we can create a picture of vertical angles by simply making two lines intersect. And vertical angles are going to be across from each other when those two lines intersect. So I'm going to call this angle 5 and angle 6. And then we can say that angle 5 is congruent, so there's that symbol, to angle 6. So in the next portion, we're just going to work with those angle relationships. So this question in example 1 asks us to state the complement of a 63-degree angle. So the complement of a 63-degree angle is going to be the angle whose measure adds up with 63 degrees to make the pair complementary. So complementary, that should trigger for us, okay, I should think, okay, wait a minute, that is 90 degrees. So that's what I'm thinking. So I want to say, okay, 90 minus 63. Well, if I work that out, that gives me 27 degrees. So the complement of a 63-degree angle would be a 27-degree angle. All right, so the next one is your turn. You're looking for the supplement of a 63-degree angle, and hopefully supplement makes you think something. Supplement should make you think 180 degrees, so you decide what the supplement of a 63-degree angle is. So hopefully you took 180 degrees and took away the 63, and if you work that out, you end up with 117 degrees. In example 2, we're finding missing angle measurements. So we're going to relate what we know about equations with what we now know about angle relationships. So we want to determine the angle relationship. Determine the angle relationship. Set up an equation. Solve for the variable. Plug in for the angle measures. And make sure you check your work and that it turns out to be something reasonable. So we determine the angle relationship in this picture. What picture does it look like? Well, these angles, hopefully, you've determined that these angles are supplementary. So they should add up to 180 degrees. So that means that I can take x plus 15, the first angle, and add x plus 5, the measure of the second angle, and that should equal 180 degrees. And then from there, we solve an equation just like you already know how. So we have like terms. I want to simplify before I solve, so I've got like terms. So that is going to create 2x for me. And I have like terms in my constants, and so that's plus 20. And on that other side, I have equals 180 degrees. I want to continue to solve, so I'm going to subtract 20 from both sides. That leaves me with 2x is equal to 160. And hopefully you realize you need to divide both sides by 2. And so x is equal to 80. Now that gives me x. That does not give me the measure of the angle. So I need to make sure I'm plugging in now. Okay, so I'm going to separate my space here. My first angle was x plus 15, and so my first, or x plus 15 degrees. So that means it's 80 plus 15, and so that first angle is 95 degrees. My second angle was x plus 5 degrees, and so that's 80 plus 5, and so that is 85 degrees. Now I do want to think through and check, does that make sense? I know that they should be supplementary, so I'm going to go back and say, okay, 90 plus 85, yep, that's 180, so that makes sense for my problem. In the next example, again, you start with what is the angle relationship that you can see. Well, hopefully you realize that all three of these are created inside a right angle, so the angles that exist there should add up to 90 degrees. So I can take the angle of 22 degrees, and I should be able to, let me take that degree sign off there when we're doing the equation, and I can add that to 2x plus 2, the second angle, and I should be able to add that with 4x minus 12, the third angle, and those together should equal 90 degrees because they are inside that right angle. So I just solve equations. Once I have that established relationship and established equation, I'm going to combine my like terms. That's going to give me 6x. And I have like terms in the constant. Watch that this one is a kind of a negative or a minus. And when I've got the 22 and 2, that's 24 minus 12, so that gives me plus 12. And then on the other side of the equation, I still have that equals 90. So then I solve my equation. Got to divide both sides by 6 to get that x by itself. And I get 13. Now that is not the measure of the angle, that is just my x. So I want to make sure to find those angle measurements, just kind of separating my space here. One angle was 22 degrees, the next angle was 2x plus 2 degrees, so that's going to be 2 times 13 plus 2. So that is going to give me 26 plus 2, which is 28 degrees for that one angle. And the other angle was 4x minus 12 degrees, so that's 4 times 13 minus 12. So we've got 52 minus 12, which gives us 40 degrees for the other angle. Now I want to think through my check. Let's make sure it makes sense. They're supposed to all add up to 90 degrees. So I had 22, I have 28 and 40. And I want to add those up. 8 and 2 gives me 10. And I've got 4, 5, 6, 7, 8, 9, 90 degrees. That makes sense for the problem. So that's good. I've got 40 degrees and 28 degrees for my angle measures. So bringing together the angle relationships that are new with the equation solving that we already know. So for this last example, you're again thinking through the angle relationship. Hopefully you recognize this kind of picture. We've got two lines intersecting and we've got angles that are across from each other. So this creates vertical angles. What do you know about vertical angles? If you don't have that memorized, look it up in your notes. What is true about vertical angles? Vertical angles are congruent. So that means those two angles have matching measures. So our equation is a little bit different here. We're not adding things up. We're setting them equal to each other. So my first angle of 6x minus 10 has to be equal to the other angle of 2 times the difference of 4x minus 16. And then we solve the equation from there. Now on the right-hand side, I've got to simplify. I have to distribute. So that gives me 8x minus 32. And now I need to kind of get all the variables to one side and all the constants to the other. I'm going to subtract 6x from both sides. You don't have to do that. You could subtract 8x from both sides, do it the other way, but I like my variables to be positive here if I can. So that's going to give me 2x minus 32 on the right and negative 10 on the left. And then I'm going to add 32 to both sides, that ALE. That's going to give me 22 is equal to 2x. And I divide both sides by 2. Giving me x is equal to 11. Now remember that x is not the final answer. The 11 for x is just what x is. I'm looking for the angle measures. So the one angle was 6x minus 10, so that means that's 6 times 11 minus 10. or 66 minus 10, or 56 degrees. Now I want to make sure that matches, there's a motorcycle driving by there, I want to make sure that matches with the other angles. So we've got 2 times 4x minus 16, and we're going to plug in the x, so we've got 4 times 11 minus 16. So 2 times 44 minus 16, or 2 times, we've got 28 there, and 2 times 28 giving us our 56, which is a match, so that is good for vertical angles. So again, taking what we know about equations, applying it to what we're now learning about angles. Bring all your questions into your teacher, please.